This video is sponsored by PME Electra. Over the years, the question I got the most from people is, where do you get all the transformer parts and materials? And the answer was always too complicated. At one point, I even attempted to sell the basic parts like laminations, bobbins, and wire myself, but I realized it was not really for me. I was mostly getting the materials locally from several different suppliers because none of them had it all. And I had to purchase in bulk. And there were always some parts missing, or I had to wait for a long time for the order to arrive. After many years of suffering, last year I accidentally stumbled upon a website of an Italian company that sells power and audio transformers, but also sells transformer parts and materials for self-building at reasonable prices, and they have different lamination grains and grades, many different shapes and sizes, bobbins, end bells, insulating materials, and a lot more. And they're also located in the EU. I made a couple of orders over a period of few months and was really happy with the service and quality of the materials I was receiving. I reached out to them recently and asked if they would like me to make a video about them, since many people are looking for a good supplier in exchange for a box with some basic transformer building parts. They agreed, and instead of sending a small box with the parts needed just for the project I was working on, they shipped a giant crate of transformer building parts and accessories, which I really wasn't expecting. Unfortunately, I don't know of any similar suppliers in the US. If you're aware of any in the US, please share it in the comments. In this video, I will show you how I wound the transformers for a prototype project called Ham Champ. It's my humble take on Fender Champ circuit using a 807 tube as the power tube, and running the amplifier at higher voltage in order to get around double the power of the original Champ. In this video I will not get into details of the build itself, but rather focus on transformer calculations and winding, and I will also show you and let you hear a bit of the final chassis prototype technically finished. Of course, the most interesting for me was the materials for self-construction, and if you click here on the link, you can see all the materials they carry, which is really easy to navigate through, and you can find all sorts of useful stuff. The insulating materials, of course, laminations, bobbins, wire, end bells, mounts, brackets, every single thing, even the screws and all the hardware, the terminal pins for transformers, transformer bobbins that you can insert. Really high quality bobbins. I've used so far several of different types, and they are really good quality. I mean, I used some other producers and distributors bobbins earlier, and I must say that these are quite superior to the other ones I was using earlier. And also they have really well organized page for laminations. If you check the laminations, they are very clearly defined, and you can see the grade and the grain orientation, and you can also find the specs for each of the types they carry. So it is they really have a good selection of sizes, which can also be useful, and you can order. The ordering is also very simple. Instead of kilograms, you of course order here in grams, so you have to be aware of that. So you can find, as I said, the spec sheets for the transformers, for the laminations, with detailed dimensions and other technical details, if you like. You can also see the end bells, which you can find also for all the different sizes, and they have different types. So the ones without legs, or the ones that you mount vertically or horizontally. Okay, let's calculate the power transformer. First, I will calculate as you should, or slightly overkill. If you would be building a bulletproof amplifier, that's the way to go. And then we will make it more like our usual vintage underrated power transformer for the true risky tone. The primary is already set, but you can of course change it to 120 volts or whatever your mains voltage is, and continue to secondary windings. We have 375 volts per rectifier side at 150 milliamps. Then we have the 6.3 volt filament voltage at 1.5 amps. And we finally have 5 volt filament winding for the GZ34 rectifier tube. Once we have all that calculated, we can see in the wizard section that it would require a really large core for this overkill version. I've used the lowest magnetic flux density, so we can start by raising it to 12,000 Gauss and edit the current ratings to make it a more reasonable sized core. I lower the current of the B+ winding to 120 milliamps and filaments to 1.25. As you can see, I'm going back and forth to the wizard and checking how the changes affect the core size and other parameters. So usually I would just switch back and forth and alter the values until I can make everything work. I will use the smaller EI84 core with the bobbin size of 28 by 40 millimeters. Then I will reduce the B+ current to a minimum of 100 milliamps. Now I can add the real wire gauges I will actually use to wind these windings. I'm trying to stick to the wire gauges as close as possible to the calculated values. Once we have all the gauges added, we can check our final stack fill, meaning if we can fit all the wire to the bobbin. And we see that we have a stack fill of about 80%, which is perfect, and we can start winding. Here's our bobbin from the calculator in real life, with two 3D printed inserts or mounts we can use to mount it snugly to the winder. Setting the tension on this CNC winder takes a bit of patience and practice, but it really pays off later because it winds cleanly and tightly and makes for really good results. If you have a really thin wire, I would recommend winding from your hand because the really thin wire is very difficult to set the tension for, and any kind of mechanical issue will make it snap, and you will regret it many times. So unless you really have a perfect system for thin wire, you should try winding by hand. I secure the wire with the Kapton tape, set up the machine for the number of turns, wire thickness and bobbin width, and we are ready to wind the primary. If you check closely here, I have a piece of tape that's blocking the wire, preventing the wire from just going erratically around the winding space and catching on different things, and it's been really helpful, and it makes a big difference when you're winding the wire automatically. Of course, the position of the spool is also important, so that the wire is not rapidly pulled off the bobbin, and you want to have it at a good angle so that it freely unwinds from the spool. here I'm setting the winding parameters and making sure that the wire will start at the leftmost edge of the bobbin and then end on the right. And if you're winding, usually if I'm winding two parts of the high voltage winding, I don't use insulation in push-pull amplifiers, but all the other windings you should properly insulate with Kapton tape or a similar insulator. And we have a first part. You can see how lucky I was here that I just finished the spool and I have just a few turns left on it. Sometimes it happens that you wind thousands of turns and then just when you're short of a few hundred, you run out of wire, which can be quite painful. But in this case I was lucky. So as you can see, I'm winding the second part of the secondary without any insulation in between. Since these windings are they are part of the same circuit and they are at the same potential, there is no real need to have them insulated other than the wire itself, which is I'm using dual coat wire, which can withstand even many kilovolts and high temperatures. But of course, if the space is not an issue, you can put one layer. It's not gonna hurt. It's a good practice, but it's really not necessary for this for the voltages under 500 volts. It's not gonna really make a difference. Here I'm setting the wire for the filament, the 6.3 filament. This is, I think, the thickest I would wind on. You can also wind this by hand, which I will show for the 5-volt filament. It's not. There is no real benefit with winding it on the machine, but it would be if you have a thinner wire for the filaments, if you're using separate filaments, or if you're winding a filament from, you can also wind it using a thinner wire, but you double it, so you wind 2 times the same number of turns of thinner wire, and then you combine it in parallel to get the desired wire gauge or current rating. Then it's easier because you can wind a neater winding, and you can set the tension more easily. So that can also be done. But here you can see I'm winding the 5-volt filament winding by hand, and I'm usually winding it. You can see it looks a bit awkward because I'm winding it in this direction, but I'm trying to keep it to wind it the same way, in the same direction as I wind the rest of the windings. So that's why I do it this way. It doesn't really make a difference in this application, but it's also good practice to keep, unless otherwise specified, to keep all the windings in the same direction, so not to have any issues with phases. If you would be doing the audio transformers, that could be a problem, or if you're combining different windings. So it's a good practice to wind it in the same direction as the rest of the windings. You want to make sure that you wind these filament windings tightly, because it's important not to have later some buzz or anything from them. So they should be secured snugly, and also press them with Kapton tape and secure them that way as well. Also the potting, of course, in the end would, if you're using a good compound, it will keep the wire really firm, and all the laminations and windings. So it's also critical to have high quality potting compound, because I had issues with cheaper enamel or something that's not specifically made for transformers and motors. You will get buzz. And here's the finished bobbin. You can see quite a few wires. And now it's time to remove this dual enamel or lacquer, which is never a fun part, especially if you have thin wires. It takes this is really time consuming, and removing this insulation and the wiring, soldering the wires, the lead wires to these wires, is the worst part of transformer winding. That's why you have to have there are some machines that can do that using heat, or but never got around to doing that. If you have if you know some cheap machine that can do this for gauges from 0.1 millimeters to 1 millimeter, let me know in the comments if you can recommend something that can speed up this process of removing insulation from the dual coated wire. Here you can see I'm adding the leads, soldering the leads to the wire, and then putting the heat shrink over it just to have it secure. And this is the part you really want to pay attention at, not to miswire or mix up the leads. It can be hazardous later when you test the transformer. So make sure that you wire the proper leads together if you have center taps, and also make sure to put a good heat shrink tubing on it, so that you avoid shorts later on. Once you have the transformer assembled, of course you will have no access to these parts, so unless you disassemble the transformer. So it's better to do it properly the first time. And also you want to remove the insulation from the wires really well, because later if you when you try to solder it, if you don't have good soldering, if the solder doesn't stick well to the material, to the wire, well, if the solder doesn't stick to the wire, to the lead wire, you will have losses, and it will overheat and stuff like that. So this is the part you should really do diligently, and not to have any issues later after such a hard work and a lot of time involved in winding and making and assembling and potting and everything. You can see how crowded it gets. If you're using the transformer from the depending on the way you are going to mount the transformer, if the transformer is going to be mounted through the hole, you know, like horizontally, and then you would have to have all the leads on one side, so that they can all go through the bottom of the end well. If you would be winding the vertically mounted transformer, of course, then you could wind on two sides, on the top and the bottom of the bobbin, which you can then you can have the primary windings on one side and the secondary on the other, like you have usually on the output transformers. But if you mount power transformers vertically, you can do the same and separate, and make separate the primary windings, and you can add also, for example, primary winding on one side and the filament winding on the same side, and the rest, the high voltage and rest of the windings on the other side. So that's a good thing to keep in mind, how you have to think in advance how you are going to mount the transformer. Also, when you're winding, you should keep the windings, the wires where you start and where you end the winding is important, because you can that way, if you have good layout from the get-go, you can it makes life a lot easier at this stage where you have to assemble the transformer. And I also secure the windings with a couple of layers of Kapton tape, and that's usually how I even leave it finished nowadays. I used to put this pressed paper, which looks nice, but it's really time consuming and unnecessary, just to go into all that trouble just for the aesthetics of it. So I just nowadays put the Kapton tape, and since the transformers winding are not exposed, so you don't even see it, the end bells will cover it, and it will not be seen from the outside. So I think it's really waste of time to do so. It doesn't have any other benefit than that. Here you can see the finished bobbin with all the lead wires attached, and now it's time to put to insert the laminations. For power transformers, push-pull transformers, we go we put first assemble all the E laminations. So we go one E lamination from one side, the other E lamination from the other side. You have to be careful when you assemble it in this way to put to make sure that you don't take two laminations at the same time. That will make a gap, which will be difficult to. I mean, you will need to put then two I laminations to make it work, but it's just becoming messy after that. So this can also be tedious, and you have to be very careful not to cut your fingers while you do this. If you have, I believe these were the 0.35 millimeter laminations, which are nicely finished. So these are the higher quality laminations, but if you are using some cheaper ones, usually the cheap 0.5 millimeter ones are they are not really cut properly and finished properly. So if they can really cut you. So you have to be concentrated at all times and make sure to handle the laminations correctly. Also, you can bend them, and then they are unusable because they will mess up the whole core. But this way you can see I'm tapping lightly with the plastic handle of the screwdriver, not to bend the lamination and not to destroy it. So I'm just lightly tapping from all sides until it fits snugly to the bobbin. And once you have the whole core assembled, you also want to make it even by tapping from all sides to get all the laminations aligned and flat before you insert the eye laminations in the holes on the sides. Now with inserting the eye type laminations, you also have to pay attention not to insert it between in between the places where you should insert it. So sometimes you will insert two laminations because sometimes the gap might look like there's a space to put another one that you missed, but it's not really the case. So you have to really pay attention and also make sure not to bend them, because sometimes if you try to push the eye lamination too rapidly, it will also bend. So this also takes quite a long time. There are also dedicated machines that do that automatically, but they are very expensive and you need to have a machine for each lamination, which is not, unless you really have a larger production, it doesn't make sense. Doesn't make sense. And here we have the our sponsored PMA Electro provided of course the bobbins, the wires, the core, and these beautiful end bells which I used, and they have really high quality parts. I cannot stress it enough that it makes a really big difference when you're working with these materials which are higher quality, and it's a pleasure to work with those. I really enjoyed this whole project, and the amplifier turned out really great. I have my friend Jimmy play and test the amplifier. Unfortunately, we only recorded it with a phone microphone, but even through the phone microphone, you can hear first of all how great of a player he is, and second of all that the amplifier really has a nice character and a really good sound. Here you can see I'm pulling the wires through the end bell. Also in this stage you want to not to pull too hard. You want to make sure that all the wires pass through equally, and also not to forget the two eye laminations that are at the end. The one just fell out, as you can see here. So many details in transformer building that you have to think about and be aware in advance, because later it's very difficult to go back, if sometimes not even possible, but very difficult sometimes to correct the mistakes you make in the first stages. Okay, so it's time to calculate the output transformer using my online transformer bundle. You can check it out on my website, in the link in the description. And For the output transformer, I was not really sure what to use for primary impedance, since this is not a standard circuit for 807. So I wound sort of a universal multi-tapped primary with 3 different impedances and 2 secondary impedances. So I started by filling the known data like the DC primary current and then the bobbin and core size I was planning to use. Now, I could edit this out, but I thought it would be useful because it shows a trick I use when I'm not really sure about the exact specs of the transformer. So I left it here unedited, and you can see exactly how I go back and forth and edit the flux density to get the desired number of turns. And then I will change impedance and note the number of turns for each of them, starting at 5 kilo ohms and ending with 8 kilo ohms. You can see how I'm modifying the lowest frequency. Of course, we know that the guitar has the lowest frequency of 82 hertz, but of course you don't want to use exactly that value because you want to have you want to be sure that especially if someone plays a drop D or whatever, you don't want to have exact cutoff at that frequency. So usually you should go at least to like 60, but I'm trying different things, and it will definitely make a difference and shape the tone if you go really low, like if you calculate for of course there are different parameters which affect it, but if you calculate it for really low minimum frequency like 20 hertz, like for hi-fi, you might get too many turns in primary, which will if you are not using if you're just using a simple primary, like secondary and primary winding, you will lose a lot of top end, and you will get really boomy bass, depending on the amplifier, of course, and the circuit. So usually it is important to know that each type of amplifier, each topology, whether it's single-ended or push-pull, or if you're using pentodes or triads, or if you have a circuit, different tone stacks like Fender or Marshall or Vox, each of the specifics of the amplifier have an effect on the bass response and treble response. And with transformers, it's important to have the primary impedance affects the low response, and the primary impedance is affected, the primary inductance, and the primary inductance is affected by the size of the core, and of course the permeability of the core, and the number of primary turns. So these are the 3 main parameters that affect it. But if you have too many primary turns, then you run into a problem that you have higher leakage inductance, which is again diminishing the high frequency response. And in order to fix that, you have to choose a different interleave system. So if you have just one interleave, if you have no interleave, you're gonna have a significant roll off of high frequencies, around
5, 6, 7 kilohertz, 8 kilohertz. But if you make it if you make more interleaves, it will also affect the feel of the sound of the tone on the guitar amplifier. So there are many different variables which can affect the tone. So for guitar amplifiers, most of the time, of course, depends on the brand you like, but if you like let's say Fender amplifiers, most of the time for the Tweed era especially, you have simple windings, so no interleave for single-ended, and maybe one interleave for push-pull. So it's a simple way they do it. Okay, so here we can see the PMA Electra provided bobbins with terminal pins that you can insert in these specially made bobbins, and this is really useful if you are making prototypes, and if you have multiple taps and you don't want to have the mess of wires that you just saw in the previous part where I was showing the power transformer. So if you don't want to solder the leads and go crazy with that, this is a really good solution, because you can remove, so before you even start winding, you remove the insulation from the wire, then you wrap the wire around the terminal or solder it directly to the terminal if you're confident enough that the wire will not snap and you have to desolder it later. And then you just, when you finish, again, you remove the solder and you solder the wire to the terminal. Remove the insulation and solder the wire to the terminal. And once you finish winding the bobbin, you don't have to do any work after that with the lead wires, because you already did it in the process. And believe me, it's way easier that way. Even though it seems like it's the same thing, it's really not, because that way you it's a lot less tedious, and once you finish the winding, it's all done. You can test, of course, the continuity with a multimeter to make sure that you have the contacts while you're winding, you have the continuity. And here you can see the beautiful, so you can use the heat shrink for this, but this kind of tubing is like a cloth impregnated tubing that's really useful for winding, because it's the right size, so you don't have to use the heat gun to shrink it. It's already the perfect size and perfect flexibility for the, you just cut it to size, and that's it. We have our spool of wire, and as I was saying, this is good, because then you can just finish the bobbin and transformer, and later you can add the wire, just solder the leads to the finished bobbin, and work like that. Of course, it depends again on what you prefer, because then you have exposed terminals, which can be problematic if they are on the open chassis, as you will see, or you saw already at the beginning of the video. But you can have shorts, or someone can accidentally touch it in the while it's on. So it's if you're using this method, it's also recommended that you put heat shrink tubing once you put the wires in. when you solder the lead wires, to also put heat shrink tubing to protect the contacts from being exposed. As you can see, I'm using the X-Acto knife to remove the insulation, and it's a lot easier to do it. I mean, still tedious, of course, like everything else in transformer winding, but you can. It's a lot easier to do it separately on separate leads of wire. When you don't have like 20 wires, 20 wires in a small place where you cannot really put the X-Acto knife. This is a lot easier, and still tedious, but easier. For the thinner gauges, I'm using even the scissors. Of course, if the wire is thicker, you should use the pliers, wire cutters. I secure the wire with the Kapton tape, which you saw probably in the previous videos as well, and it works really well. It's really a proper material. I used also got from PM Electra the insulating material, the yellow tape, the yellow transformer tape. But those yellow transformer tapes, probably there are also different types, but the ones most commonly used that you can find anywhere, those are not really meant for high temperatures, and if the transformer will be in a really hot environment, those might not behave as expected. And if you would have usually in tube amplifiers, you get a lot of heat, especially if people leave them on and forget to turn them off. They can really get hot, and I'm not sure that insulation is good for this Kapton tape. You can light a fire next to it and it's not gonna go anywhere. So I recommend it. And here I'm setting up the CNC machine, and this is also a critical step, as I said, so you want to take your time and set it up properly. Here I'm demonstrating the freehand winding with a really thin wire for the primary of the output transformer, and this took some practice, but I encourage you to practice it. You might burn your fingers in the beginning, but this is if you start with a hand winder and you get used to navigating and feeding the wire by hand, it's really going to help you a lot, because these thinner gauges of wire are really difficult to set the tension on, as I mentioned. So if you wind by hand and you get good at it and you get this practice, it's really gonna encourage you to wind it and it can be really handy because you're not dependent on the fancy winder or anything like that. You can just use anything, even a hand drill to put a chuck in it and control the wire by hand, which is a really good technique to master. It's difficult in the beginning, but with a little bit of practice, you will really get the feel of the wire. If you're winding like guitar pickups, it's really critical to know how to do it. And of course, with these gauges, which are from 0.1 to 0.2, if you wind it by hand, which I recommend, it's really beneficial. But for higher, thicker gauges from 0.20 or 0.25 millimeters upwards, the CNC really shines. The CNC winder, because if you set the tension properly and you have thousands of turns, you can just rely on the winder and the tensioning mechanism to keep it aligned, and you just press start and you don't even have to control the wire if you have everything set up correctly. So if you have a repeating winding of large numbers of turns, it's very useful. As you can see, I'm holding the wire with two hands. So in my case, with my left hand, I'm making sure that because you cannot see the spool. The spool is not the one that you see here, but I think it's under the winder. So I'm controlling the tension from the spool with one hand, making sure that the wire is being unwound properly, and with my right hand I'm giving the tension that's going to the bobbin. In this way I have better control over the wire and prevent it from snapping, and also keeping the proper tension, which also comes with practice. But you get a really good feel after a really short period of time, especially once the wire snaps. Like if you have the wire snap several times, multiple times, and you get crazy with it, you will quickly realize how to control it. Also important thing to mention is that the speed of winding also plays a role. If you have lower speed, of course you're usually reducing the risk of wire snapping. So if you start with lower RPM, it's good for the beginning to start with lower RPM so you can see what's going on and control the situation. But of course, if you have 3, 4, 5,000 turns, it takes a long time, and it's tiring from that aspect. So you want to find the sweet spot of having the fastest RPM, highest RPM you can set where the wire doesn't snap easily, and you can control the situation, and you also save time and make it more convenient. So the first step for the lowest impedance we selected, which was 5K, I believe, or is 2,441 turns, and so we will have separate. We would just add the rest of the number of turns for rest of the taps. So we would have, I think, 5, 6, 7, and 8K, something like that. And we will then be able to test. Of course, I did the test. I noticed some strange behavior. Finally, I used the higher load. I think this in single-ended mode, the tubes really like to see a lot of inductance, and they like to see, I mean, primary inductance, and they like to see higher number of turns, of course. So it's I think both the DC resistance of the primary plays the part, because the B plus is going directly through the. It acts also as a sort of choke for the plate supply. So I think it's if you're building a similar amplifier, you should use a high value. That's why the Champ uses like 8K in the primary. Regardless of what the data sheet says, for guitar amplifier, you definitely, I think these high gain guitar amplifier circuits, you want to use higher loads to a certain degree, of course, but I think the sweet spot for this 807 was at 8K, if I'm not mistaken. It is quite possible that even higher ones would work, which would be a good thing to try in future. You will notice that it has a completely different character, of course, than the 6v6 in Champ, and I think it's more it's more useful for recording. Not if you want like a distorted sound, but if you want to record, I think for jazz and for pop and any kind of music where you want to have good clean tone, but you can also connect. It really works well with the pedal board, so it's a really good combination for both very clean but still harmonically rich sound, and it works really well with pedals. If you have any questions regarding transformers or transformer winding, feel free to write in the comments and ask your questions. I would be happy to answer them. And also, if you would like to wind your own transformers, check out my website. Check the links in the description. I have several calculators and spreadsheet version with tutorials, PDF tutorials. But if you get the bundle, so you can check it on my website. If you get the bundle of any sort, automatically you would get the online bundle and the other way around. So you can get a good deal to get all the calculators, spreadsheets, tutorials, and access to the online calculator. If you would like also to support me in other ways, you can check out my Patreon page. Now you can see where the price of the custom transformers come from. If you just check, because this video is minimally edited, but it's still edited a lot in comparison to the real time and the effort it took to finish each of these transformers. If you check how much work is involved, how much, not to mention the materials, the time and everything else, but just how much skill and effort it goes into winding it, and how many things you have to keep in mind and consider when you're doing it. If you have a specific transformer that you wind 1000 of and you have everything set for that, it's not too difficult, still not easy, but a lot easier. But if you have to make something custom, you have to do custom calculations, you have to make sure that you did the calculations correctly. Then you have to have all the materials for that, and you have to really pay attention and really concentrate to have everything done correctly, and you have to think of many things in advance. One little mistake at any of these stages, and the later the mistake happens, the worse it gets, because if you screw something up at the very end of this process, you wasted all the time, the effort, plus the materials, and you get annoyed, of course. You have to throw this, and you have to start from scratch and do all of the work again. So doing one-off custom transformers is something that I did a few times for customers and for people who wanted some custom or specific transformer, and many times it didn't really play well, because in the end you are doing something for the first time, and usually the customer is also not really sure what they want, or they didn't test it, you haven't tested it, and it can cause issues and not really good results in the end. So usually if you want to make something custom, you need to really make a lot of tests. You need to first build the whole prototype of the amp, if you don't have the amp already, or the circuit. So that takes a lot of time and money, and then you have to wind the prototype, go through this whole process. Once you have the transformer ready, you have to perform all the tests to make sure it works electronically, technically, and also to check the tone and check everything, the phases and all the little details. And once you're sure that it's that everything is working fine, then you can make such a final product. But if someone just asks for something and you have no idea if that amplifier or circuit, how it behaves in practice, and you just guess and build, it might not work, or it will work but it's not going to sound good, or there will be some other issue, some oscillation, or so there are many things to consider. That's why first understanding and checking how the original transformers for specific circuits and amplifiers were built is really helpful to get the feel for what makes sense and doesn't make sense in transformer build is important. So you can see I switched also to here I'm winding secondaries. I have 2 taps for secondaries as well, I think 4 and 8 ohms, and so you can select different combinations for primary and secondary, and it's a good way to not waste a lot of time. If you wind a prototype, you are not sure what primary impedance you need, or what primary impedance sounds the best. This multi-tap transformer is a good way to go. Of course, I would build it in such a way that you have a secure way to test it, an easy way to test it, so not like I did in this case with alligator clips with high voltage around, but to have a mechanical rotary switch or even a relay board, so you can switch between different taps in real time and test the amplifier that way. That's a good way to save time and money by having all different scenarios in one transformer, and then once you find the correct one, the correct primary impedance, you can wind just specific transformer for the specific circuit. And finally, after you have all the taps wound, both primary and secondary, you see that in this case you don't have to solder the lead wires. You just have, after all this work, you have a ready coil, so you can just insert the laminations. In this case, since it's a single-ended amplifier, we need to have a different way of inserting the laminations, which is called the butt stack. You just put all the E laminations from one side and all the I laminations from the other, and you will see how I like to do it so that it's easy to mount, because the I laminations are hanging in the air. So I insert all the E laminations except for the two which I reverse, so I put from the opposite side at the very ends, and they act as a mounting bracket. Then I take just a piece of paper, just a normal a sheet of paper for the printer or whatever, and I put it underneath. And then I put, of course you can cut it exactly to the size, but sometimes it just moves and shifts. That's why I like to do it this way, where I just cut the ends, and later do it with the X-Acto knife if necessary to make it pretty. But this way you have everything mounted properly, and then you can see these nice transformer brackets from PM Electra, which are dedicated for these bobbins, and then you just secure it. I like to put the eye laminations from the on the top, so that the bracket will hold it in place. And then I use a zip tie to hold it, because before it's potted, it will move. So I like to secure it with a zip tie, and then I pot it in this compound, this resin for motors and transformers. Okay, here's the chassis for the prototype I'm building. I got this chassis from Tubetown, the German supplier. They have really good pre-cut, laser cut chassis, and I'm punching the holes for the tube sockets. Now you will be able to hear Jimmy testing the amplifier. I use the speakers from my 5F4 build, Tweed Super. It has two, I think it's P10Q Alnico speakers in the pine box, so it's really powerful, and this, you can see that 807 has no issue driving this at a really high level, high power, and it stays really clean, unlike the Champ, which really distorts straight away. This has a lot of headroom, and it's a lot more capable to get different palette of sounds. So here we go. Okay, let's see what's in the box the PM Electra, our today's sponsor, sent us. So I was really excited to receive that crate. I was expecting a small box because I just asked them to send me a couple of the sizes of and materials that I need to finish this champ project. But they were really generous and sent the whole crate full of materials. You can see the wires, different types, stranded and single core. Really high quality stuff, and these ones are really good for. I use them even for as a bus wire for amplifiers. Some of the thicker gauges. They also have really thin gauges for which can be very useful to have as leads for smaller output transformers where you need to put a lot of windings, but you have a limited space, so you don't want to use too thick of wires. Also some Teflon insulated wires and different colors, which is also useful to separate different windings. And of course there are standards you can follow, but even if you just wind it on your own, you can still make it look nice and separate the different windings according to colors, whatever color scheme you want to use. You saw previously in the video I used these wires for the build in the video, and I used practically all the materials from PM Electra for this project. So the bobbins and laminations and wires and insulating materials, Kapton tape, they sent everything. Here you can see the box with bobbins, and these the pins, the terminal pins of different shapes and sizes. And you can see that, and these bobbins are really good for those really good plastic, good material. And some people mentioned that they like to do 3D print the bobbins, and some people build them from cardboard, but I really think that these bobbins are worth the money, because they can handle high temperatures. They're really stiff and firm, so that mechanically they don't break, they don't bend, they don't have any other issues that you might have problems with. I don't have experience with 3D printed ones, but I don't think they're a good idea, because in the very hot amplifiers they also might, after many years, they will probably deteriorate a lot easier than these ones. You can see they send quite a lot of different sizes, and I use I use the one for power transformer, and I also wound the choke, which I didn't show in this video, but it's the same process. So it's just a single winding. These are also nice. They are a bit lighter, different color, and slightly different material. Also very good. And they're also the ones with the section with 2 sections, so you can wind primary on one side, secondary on the other, and you get full insulation between the two layers. And you can also it changes also the capacitance, and it also helps with leakage inductance if you're winding. If you have multiple sections, of course, just one is not going to make that much of a difference. And in this box we have a lot of cardboard, and we have many different boxes. Let's see what's inside. So here's the copper, the thick copper tape, which those are like strips that you can use to put as a band around the transformer for power transformers to reduce the stray magnetic fields to reduce the spread of the magnetic field and noise in the amplifier. They also sent this box full of screws, washers, nylon washers, and also the like a nylon or plastic inserts that you put for the screws to insulate the screws from the laminations to prevent the losses also. So different sizes, M4s, M5s, etc. Also the different types of, so these are the inserts I mentioned, and different types of screws, and also the black ones are the same insulating materials. Now we have the mounts, so different types of brackets for mounting the transformer and end belts. So these are the style I think Marshall used, some of the European manufacturers used. They're like open frame mounts, and of course here are some of the different types of full end belts for the transformers. They sent me also a few with their logo, which I think looks really nice. These are the black ones. They have from what I saw on the website, they have the black and of course the metal, the bare metal. But I've seen, I also received from them several different colors. I guess you could get custom colors. Here you can see a beige one or some kind of greenish beige color. You can. I also received 2 or 3 different colors, so I presume that maybe you can order specific maybe specific colors. And of course we have the most important thing, the laminations, which are really nicely packed, I must say. This is sort of a greased paper, similar to one used for baking. It's really it really keeps the laminations intact and easy to handle. And you can see that this is really professionally packed, and also the quality of these laminations. I have been ordering for a long time from them now. I think it's many months, and I have many orders before this video and after. and every time I receive really premium quality. Sometimes if you order from some cheaper places, you get all sorts of surprises, like rust or just poor quality. But this is top notch, and I can really highly recommend PMA Electro. They also include the wire in their offer, so you can order enameled wire for transformers, even the really thin stuff. Like this one is mostly for even for like a guitar pickup, but they carry all the different gauges, and also the insulating materials. So they have specific tapes like this one for insulating the bobbins, and it fits specific bobbin size, so you don't have to cut and lose time. You can just put this between layers if you're making like a hi-fi output transformer with multiple layers. You can put a layer between each layer of this tape in between each of the copper layers you will wind, to make it more neat. And also you can see Kapton tape, of course, and the tubing, the heat shrink tubing, and then other non-heat shrink tubing like this one for 4 kilovolts, or they have many different ones for specific purposes. And these ones are very useful because the standard heat shrink tubing you can find in normal stores is usually good for up to 4, 5, 600 volts the most. And if you're winding something, especially for RF amplifiers and similar, you need to be careful, because just using the basic heat shrink tubing is not enough. So you should use something like this, which is rated for 2 or 3 or 4 or 5 kilovolts, just to be on the safe side. You saw me use these yellow ones. I really like those. They're really good for winding. I really like those. I think they are not rated for such high voltages, so probably also 500-600 volts, but they work well. You can see different sizes of Kapton tape. That's also my favorite. And you can see a lot of these other types that I mentioned. If you're winding lower power transformers or lower or like output transformers, you can use mainly for solid state stuff. I presume you can use these yellow type tapes. I believe they also have different ratings. I'm not really sure about their temperature capabilities and voltage capabilities, but I see a lot of people using them. So thank you for so thanks to our sponsor, and so special thanks to our sponsor PMA Electro for sponsoring this video, and thank you for watching. I hope you enjoyed this adventure and this project. Thank you for watching, and stay tuned for next projects.